Next, we are going to study about supermesh analysis. Already we have discussed about mesh analysis, in which we are using Kirchhoff voltage law or mesh equations to find out the currents or voltage drops, etc. And now we are going to deal about super mesh analysis. Then what is the difference, basic difference between a mesh analysis and a super mesh analysis? Suppose any of the branches in the network has a current source, then that will be very difficult to use the conventional mesh analysis. In that case, we can make use of a super mesh analysis. Okay, right? Suppose any branch contains a current source, we have to use super mesh analysis. Otherwise, that will be convenient to use the ordinary mesh analysis. And a super mesh that is constituted by two adjacent loops that has a common current source. So suppose two consecutive branches has a common current source, then we can constitute a super mesh by making use of those two adjacent meshes. Okay, right? അതായത് നമ്മുടെ സർക്യൂട്ട് ബ്രാഞ്ചിൽ എന്തെങ്കിലും കറണ്ട് സോഴ്സ് ഉണ്ടെങ്കിൽ നമ്മൾക്ക് സാധാ മെഷ് അനാലിസിസ് മാത്രം യൂസ് ചെയ്യാനായിട്ട് ബുദ്ധിമുട്ടായിരിക്കും. ആ സാഹചര്യത്തിൽ നമ്മൾക്ക് സൂപ്പർ മെഷ് അനാലിസിസ് യൂസ് ചെയ്യാം. സൂപ്പർ മെഷ് ഫോം ചെയ്യണമെങ്കിൽ നമ്മുടെ അടുത്തടുത്തുള്ള അഡ്ജസൻറ്റ് ലൂപ്പുകൾ രണ്ടെണ്ണത്തിൽ കോമൺ ആയിട്ടൊരു കറണ്ട് സോഴ്സ് ഉണ്ടെങ്കിൽ നമ്മൾക്ക് ആ രണ്ട് ലൂപ്പുകളെയും കൂടി ഒരുമിച്ച് ചേർത്തിട്ട് നമ്മൾക്കൊരു സൂപ്പർ മെഷ് ഫോം ചെയ്യാം. അതാണ് സൂപ്പർ മെഷ് അനാലിസിസ്. ഓക്കെ, നൗ ലെറ്റ് us understand the concepts more clearly by doing an example. Okay, by doing a sample problem we can understand the concept more clearly. And here is the question given to us in order to understand super mesh analysis. Determine the current in the 5 ohm resistor in the network shown in figure below. Okay, this is the network given and we have to find out the current in 5 ohm resistance. This is 5 ohm resistance. We have to find out the current flowing through this resistor using this concept, mesh analysis. If 50 volt voltage source is there, then 10 ohm resistance, 5 ohm resistance, 2 ohm and 1 ohm resistance, and 3 ohm resistance. And this is a current source having a magnitude of 2 ampere. 2 ampere current source is there additionally. So let us redraw the figure once again in order to discuss the concept in detail. Okay, if we look at this figure, we can say that this mesh and this mesh has a common current source of 2 ampere. Before that, let us mark the meshes using labels A, B, C, D, then E, F, and finally D, G. Okay, the meshes C, B, E, F, C and D, C, F, G, D, these two meshes. Suppose I'm marking this one as mesh 1 and this is mesh 2 and this is mesh 3. The mesh 2 and 3 shares a common current source 2 ampere. In this case, in such cases, we cannot apply ordinary mesh analysis because a common current source is there in between them. In this case, we have to consider both mesh 2 and 3 together, known as a super meshes. Otherwise, by using mesh 2 and 3, we can form a super mesh. Okay, let us go deeper into this topic. Before that, I'm just giving an introduction, that's all. Suppose we have three meshes, 1, 2, and 3. And now try to understand this much. The mesh 2 and 3 shares a common current source 2 ampere. That's why we are going to use super mesh analysis. Okay, right. Now let us try to understand, try to write the mesh equations for each mesh separately. For mesh A, B, C, D, A. For mesh A, B, C, D, A. A, B, C, D, A. For mesh A, B, C, D, A, let us write the mesh equations. Mesh equation, that is KVL itself. If we write the mesh equation, we can say that 50 minus a drop is there. Before that, we have to write down the currents. So we have to mark the currents. Suppose the current I1 that is flowing in clockwise direction. Previously, I said in the earlier video that we can take the direction of current according to our decision. That will not make any changes in the final answer. We can choose the direction, okay, whatever it may be, whether in clockwise or in anti-clockwise direction, okay. And suppose I2 is also flowing in clockwise direction, and I3 that is also flowing in clockwise direction. Let us assume the currents are flowing in clockwise direction. That doesn't make any changes in the final answer. Try to remember that, okay, right? Now we are writing the KVL. 50 minus, what is the voltage drop across 10 ohm resistor? That will be 10 ohm into corresponding current flowing through 10 ohm resistance. What are the currents, or what is the current flowing through 10 ohm resistor? If we look carefully, we can say that current I1 that is flowing downward through 10 ohm resistance, okay, right? Current I1 is flowing downward, as this is in clockwise direction. I1 is flowing from A to B, then B to C in downward direction, as we assumed that I1 is in clockwise direction. At the same time, this current I2 that is also flowing through this loop. So the current I2 is flowing upward through the same 10 ohm resistance. I1 is flowing downward, whereas I2 is flowing upward. Both are in opposite directions. So the effective current or resultant current will be the subtraction of I1 and I2. Okay. If both are in same direction, we have to add it. If both are in different directions, we have to subtract it. Okay, then corresponding voltage drop is 10 into I1 minus I2. Why this minus sign? Because I1 is flowing downward and I2 is flowing upward. Both are in opposite direction. As we are considering the mesh 1, we have to give more priority for I1. That is the rule for mesh analysis, and hence we are taking I1 minus I2. Okay. Minus, then there should be a voltage drop across 5 ohm resistance, then 5 ohm into what are the, or which are the currents flowing through 5 ohm resistance. I1 is flowing downward, whereas I3 is flowing upward, okay, right? This I1, same I1 is flowing or circulating or flowing through 5 ohm resistance in downward direction, whereas this branch loop current or branch current I3 is flowing upward. I1 is flowing downward through 5 ohm resistance, whereas I3 is flowing upward through 5 ohm resistance. So if so that we can take the resultant current as I1 minus I2. Again, this minus sign is because both currents I1 and I3 are flowing in opposite direction through 5 ohm resistance. I1 is flowing downward, I3 is flowing upward, both are in opposite direction. Hence, we are taking I1 minus I2. Okay, right? Is there any voltage drop other than this one? No. So let us close it using equal to 0. Now expand these brackets and rearrange it. Then we will get 50 minus 10 into I1 minus into minus become plus 10 I2 minus 5 into I1 5 I1 minus 5 into minus I2 plus minus into minus becomes plus 5 I2 equal to 0. Therefore, we are getting 50 equal to minus 10 I1 and minus 5 I1 is there. So let us take the effective currents as minus 10 minus 5 gives minus 15 I1 again plus 10 here. I have made a mistake. This is I1 flowing downward and I3 flowing upward. This is not I3. This is sorry, I2. This is not I2. This is I3. So there will be a difference. Okay, then plus 10 I2, then plus 5 I3 that equal to 0. Okay, 50 minus minus 10 I1 is there and also minus 5 I1 is there. So the resultant of this is 15 I1 plus 10 I2 plus 5 I3 is also there. Now let us express this equation in standard form such that the constant term should appear in the RHS side. Now I am going to rearrange it. Okay, 15 I1 minus 10 I2 minus 5 I3, that will be 50. Okay, let us mark it as equation number 1. Now look at the problem given in these two meshes B, E, F, E, D. That means this mesh 2 and mesh 3 shares a common current source. So by combining meshes 2 and 3, we can form a super mesh. Okay. By combining meshes 2 and 3, we formed a super mesh B, E, F, G, D, C, B. This is the super mesh B, E, F, G, D, C, B. That is written over here. Okay. From the second and third meshes, we can form a super meshes B, E, F, G, D, C, B. Okay, B, F, G, D, C, B. This is the super mesh. Now we have to write down the mesh equations. Writing mesh equations for our super mesh, we get let us try to start the mesh equation from here. Here it is a drop, and what is the current flowing through 2 ohm resistance? That is only I2. So minus I2 into 2. Okay, again the then we have to consider the branch FG. What is the current flowing through 1 ohm resistance? Because we are considering only this mesh. Okay, right? We are starting from E. We wrote the equation I2 into 2 ohm resistance. Then we have to write the corresponding voltage equation. I mean the voltage drop across 1 ohm, that is equal to minus 1 ohm 1 into corresponding current, that is the current flowing through 1 ohm resistance, that is equal to I3. Okay, then what is the current flowing through 5 ohm 5 ohm resistance? There are two currents. I3 is flowing upward, whereas I1 is flowing downward. So we have to take the effective current. We have to since both are in opposite direction, we have to subtract it. Then minus 5 into current flowing through 5 ohm is I3 upward and I1 downward. As we are considering the mesh 3, we have to give more priority for I3. So we have to subtract I1 from I3. Okay, I3 minus I1. Then we reached here. What is the current flowing through 10 ohm resistance? Here also we have two currents. It's I2 flowing upward, I1 flowing downward. Therefore minus 10 into I2 minus I1. As we are considering mesh 2 now, we have to give more priority. So I2 minus I1, not I1 minus I2. I2 minus I1. ഇവിടെ നമ്മൾ സൂപ്പർ മെഷ് ഇങ്ങനെയാണ് കൺസിഡർ ചെയ്തിരിക്കുന്നത്. അപ്പം മെഷ് 2-നും 3-നും ആണ് മോർ പ്രയോറിറ്റി വരുന്നത്. അപ്പം 5 ഓം റെസിസ്റ്റൻസിൽ കൂടിയുള്ള കറണ്ട് എടുക്കുമ്പോൾ I3 പോകുന്നുണ്ട്, I1 പോകുന്നുണ്ട്. I3 മൈനസ് I1 ആണ് എടുക്കേണ്ടത്. ഓക്കെ, അതുപോലെ തന്നെ നമ്മൾ ഇവിടെ എത്തിയപ്പോൾ I2 അപ്വേർഡ് പോകുന്നുണ്ട്, I1 ഡൗൺവേർഡും പോകുന്നുണ്ട്. സൂപ്പർ മെഷിലെ മെയിൻ ആൾക്കാരാണ് മെഷ് 2ഉം മെഷ് 3യും. അതിലെ കറണ്ടുകളാണ് I2ഉം I3കളും. അപ്പോൾ I2വിനും I3ക്കുമാണ് പ്രയോറിറ്റി കൂടുതൽ. ഇപ്പോൾ 10 ഓമിലെത്തുമ്പോൾ നമ്മൾ എടുക്കേണ്ടത് അതിലൂടെയുള്ള കറണ്ട് ഏതൊക്കെയാണ്? I2ഉം I1ഉമാണ്. I2 ഫ്ലോയിങ് അപ്വേർഡ്, I1 ഫ്ലോയിങ് ഡൗൺവേർഡ്. I2വിനാണ് മോർ പ്രയോറിറ്റി. ഓക്കെ, നമ്മൾ ഈ മെഷ് എടുത്തിരിക്കുന്നുണ്ട്. അപ്പോൾ I2 മൈനസ് I1 കൊടുത്തു. ഓക്കെ, ഇനി വല്ലതുണ്ടോ? Is there any other voltage drop across this super mesh B, E, F, G, D, C, B? Nothing. So let us close it as equal to 0. Now we have to expand the brackets and rearrange. If we expand the bracket, we are getting like this, and now we have to reduce. We have to find the reduced expression for this one by considering I2 here and here is there, and I1 is there and here. You have to express this equation in minimum form. Okay, right? And this is the reduced expression. Now we are going to mark it as equation number 2. Okay, now we have to consider the current source 2 ampere also. So far we have not yet considered the current source 2 ampere. We have to write down a current equation using this current source. Okay, the current source is equal to the difference between the current flowing through mesh 2, that is I2, and the current flowing through mesh 3, that is I3. So let us write it as I2 minus I3, that is equal to the current source. Okay, this is our third equation. The current source is equal to the current flowing through the mesh 2 minus the current flowing through mesh 3. Okay, now we got another equation, that is I2 minus I3, that is equal to 2 ampere. And from this equation we can say that I3 is equal to I2 minus 2. Okay, let us mark it as equation 4. Now we have three equations, equation 1, then equation 2, and finally equation 3. From these three equations, we have to find the currents I1, I2, and I3. Okay, if we rearrange the equation 3, we will be getting equation like this. Okay, so how can we find out the individual currents I1, I2, and I3 separately? I'm going to substitute equation 4 in equation 1. On substituting equation 4 in equation 1, we get, what is equation 1 here? This is equation 1, 50 I1, 15 I1 minus 10 I2 minus 10 I2 minus 5 into I3 minus 5 into, instead of this I3, I'm going to substitute I2 minus 2. Okay, right? I'm going to substitute equation number 4 into 1, means I'm going to replace the I3 in equation 1 using I2 minus 2. ശരിയല്ലേ? Equation number 4 കൊണ്ട് 1ൽ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുമ്പോൾ ഇക്വേഷൻ I3ക്ക് ഈക്വൽ ടു I2 minus 2 എന്ന് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാം. ഓക്കെ, റൈറ്റ്? 5 into I2 minus 2. That is equal to 50. That is equal to 50. Now again we have to expand this brackets and rearrange and express this equation in minimum form. 15 I1 minus 10 I2 minus 5 I2, again minus 5 into minus 2 become plus 10. Okay, that is equal to 15. Now we are getting 50 I1 minus 10 I2 and minus 15 minus 10 I2 is there. So if we add these two, we are getting 15 I2. This is equal to, I'm going to take this 10 to the RHS, then I'm getting like this. That is 15 I1 minus 15 I2 is equal to 40. Mark it as equation number 5. Now substitute equation 4 in equation 2. Then we will get, again this is equation number 4. I'm going to substitute equation 4 into equation number 2. This is our equation number 2. Okay, I'm going to substitute I3 equal to I2 minus 2 into equation number 2. Then I'm getting minus 12 I2 minus 6 into, instead of this I3 I can use I2 minus 2. Okay, minus 6 into, for I3 I'm going to replace it with I2 minus 2. Okay, I2 minus 2, then plus 15 I1 equal to 0. Okay, now expanding the brackets, we are getting 12 I2 minus 6 I2, again minus 6 into minus 2 become 12 plus 15 I1 equal to 0. Okay, now we have to express this equation in reduced form as 15 I1 minus 12 I2 and minus 6 I2 is there. So if we add these two, we are getting 18 I2, that is equal to minus 12. That is equation number 6. We got this equation from this equation. Okay, now from equation 5 and 6, we have to find the currents I1 and I2. Let us write these equations 5 and 6 together. From equations 6 and 5, we have to find currents I1 and I2. If we look at this equation carefully, we have two variables only, I1 and I2, whereas in equations 1 and 2 we have three variables or three unknowns, I1, I2 and I3 was there in equation 1 and equation 2. Now we eliminated the term I3 from equation 1 and equation 2 using equation 4. That is what we have done. Okay, now we got the reduced equations of equation 1 and equation 2. This is the reduced expression for equation 1. Okay, right. And this is the reduced equation for equation number 2. Now we have only two unknowns, I1 and I2. Two variables are there. Now that will be very easy to find the solution for this one. So we can make use of any methods, either using the solution of a simultaneous equation method, or we can make use of a scientific calculator. By any means, we have to find the solution. I'm going to show you how to find the solution for this equation using a calculator. Okay, this is a calculator I have. In this, just to turn it on. Now take the mode, press until we find this mode, enable this mode. EQN stands for equation. Then I'm going to enable it by pressing 1 because it is a first number. Okay, 1 1. Now there is a question, unknowns. How many unknowns are there? We have. Now it is asked to enter A1. What is A1 here? A1 is the constant in equation 1. First constant in equation 1 means the constant 15. Now we have to enter 15. 1 5. Okay, then press equal. Then it will be asked to, it is asked to enter B1. What is B1? B1 is the second constant. That means minus 18. We have to press minus 1 8. Again press equal. Then that is asked to enter C1. C1 is minus 12. Minus 12 equals. Then that is asked to enter A2. What is A2? A2 is the first constant in equation 2. Second equation, first attack. That is 15. 1 5 equal. Then we have to enter B2. What is B2? Minus 15. Minus 1 5 equal. Then at last it is asked to enter C2. What is C2? 40. 4 0 equal. Then we are getting the solution as x equal to 20. What is x in our case? In our case, x is equal to I1. Then again press in the equal button. Then the solution y will also appear here. What is y in our case? That is I2. This equation, from this equation we can find the solution like this. Therefore we can say that on solving we get what are our final solutions? X equal to 20 means I1 is equal to 20. What is the unit? Ampere. And I2, that is equal to y. I2 is equal to 17.33. 17.33 ampere. Now we have to find one more current is also there. What is that? I3. What from equation 4 we can say that I3 is equal to I2 minus 2. I2 minus 2. What is I2 here? We obtained it as 17.33 minus 2 gives 15.33 ampere. So these are the currents we obtained from our mesh equations. I1 is equal to 20, I2 is equal to 17.33 and I3 is equal to 15.33. Then what was our question given? We have to determine the current in 5 ohm resistor. Okay, now we have to find the current flowing through the 5 ohm resistance. There are two currents flowing through 5 ohm resistance. I1 is flowing downward, whereas I3 is flowing upward. Then what will be the result current? As these two currents are in opposite direction, we have to subtract these two currents. Okay, when which one is greater, I1 or I3? Which one is greater? I1 is 20 and I3 is 15. So current flowing through 5 ohm resistance is equal to I1 minus I3. I1 flowing downward and I3 flowing upward. Both are in different direction. Hence we are subtracting I1 minus I3, that is equal to 20 minus 15.33, which is equal to 4.67 ampere, which is our required solution. Okay, thank you.